All right, so we are on day 4. Your homework is out of the textbook. Like normal on Wednesdays, I'll pause on each of the homework answer pages so you can pause the video, check your answers, and then I'll pause on each of the worked out pages as well so you can check those. If you had trouble on anything, you can either ask next day in class or hop on a 9th period or in office hours to get those questions answered. So 81 kind of goes down long on the page, so I'll scroll down in a second. 87 and 89 are on the right there. So there's your second derivative where you had to use a quotient rule. The second derivative didn't exist at 0 or 1, so you had to put them on the number line, and then e squared was what made the numerator 0. So all of those went on the number line, and anything less than 0 wasn't in the domain because of the natural log, so we only tested stuff right of 0. And even though 1 is switching signs, the second derivative didn't exist at 1. And if you go back to the original function, where was it? The original function also did not exist at 1 because natural log of 1 in the denominator would give you 0 as well. All right, so today we're in the notes packet on day 4. So we're going to start by doing this integral. We would rewrite this as the integral of x to the negative 2 dx. So exponent goes up 1, we'll have x to the negative 1, divide out front by negative 1, and then we'll have a plus c. So in other words, this is negative 1 over x plus c. Well, let's try this one. We'll have the integral of x to the negative 1 dx. If we follow our power rule, we'll have x to the 0 over 0 plus c. So that doesn't work out. That gives us something undefined, so that can't be it. So we've got 1 over x. So another way we can think of it is what thing's derivative is 1 over x? And we've seen it recently, and you might be thinking natural log of x. So the problem with that is in 1 over x, that function is defined for all values of x except for x equals 0. So we can find area under the graph from, say, like -7 to -3. There should be some area between the graph and the x-axis. But over here, if we tried to evaluate that, say, from like -7 to -3, we can't sub negatives into the natural log. So that can't quite be it either. So, spoiler alert, you probably already saw it on the bottom, but the integral of 1 over x is natural log absolute value of x plus c. And if we look at the graph, we can kind of piece together why that is. So here's the graph of 1 over x. So Let's say we took the antiderivative, so we get natural log absolute value of x, and we're going to evaluate from -4 to -1. Well, when you sub in -1, it gives you natural log of 1. When you sub in -4, it gives you natural log of 4. Well, natural log of 1 is 0, so you just get minus the natural log of 4, which is around -1.386. So essentially what it does, because you end up doing a small minus a big after the absolute value is taken, it essentially negates what the area under the positive side of the graph would be. So basically this area here, if you negate it, matches that area there. Because this is an odd function, it's symmetric with the origin. So by doing that absolute value, if it was in the negatives, it just does it. It basically just does the positive version of it, but reverses our order that we would sub them in, which then just makes it be negative. So that's why it ends up working out. All right, so let's see if we can apply that. So in this integral, notice the numerator degree is 1 less than the denominator degree. So we had derivative of stuff over stuff as our derivative with chain rule for a natural log. So you'll often end up letting u equal the denominator, because that was the original inside. Now sometimes I think it's helpful to write these as 1 over x squared plus 3x, and then times 2x plus 3 dx, because that can make it a little bit easier to see what the leftover stuff is. Well, let's take our du over here. That gives us 2x plus 3, and then times the dx that would swing over. And notice that matches up perfectly. So this just becomes the integral of 1 over u, and then this leftover stuff is just our du. As we saw on the previous page, 1 over u, the antiderivative would be natural log absolute value of u plus c. And then just replace u with what it was equal to. And that's it. So on the next one, we'd want to recognize again, okay, that numerator degree is 1 less than the denominator degree. So maybe that's derivative of stuff over stuff. If you thought rewriting it was beneficial as multiplication on that last one, we could do that here as well. If you didn't like doing that, you don't have to do that. But we'll let that u equal the denominator, because maybe that was the inside stuff. Oops, I wrote that as a squared. This should be a fourth here. So plus 4x cubed plus 1. If we take our derivative, our du, we'll have 12x cubed plus 12x squared. And then we'll have our dx that swings over. So notice that's pretty close to our leftover stuff. We just need to multiply by 1/12 to correct it. So we can stick the 1/12 out front. We'll have the integral of 1 over u now, and then du. So our antiderivative of 1 over u is natural log absolute value of u, and we got the 1/12 out front. Don't forget your plus c on the end. And to finish it off, just don't forget to replace the u. So we'll have absolute value of 3x to the fourth plus 4x cubed plus 1 absolute value plus c. Now, if something is ever going to always be positive, you will see in multiple choice answers they will often drop the absolute value. So let's say you had gone through and got natural log absolute value of x squared plus 9 plus c. Well, x squared plus 9, no matter what you sub in for x, the x squared plus 9 part is always going to be positive. So usually in the multiple choice answer, you'll just see it written without the absolute value because we know that that is never going to be negative or 0. Okay, so just keep that in mind when you're looking at multiple choice answers. Okay, going to the next page, we've got two separate parts. So let's split this into two separate integrals. Because neither of the parts looks like it's going to be something quick. So in the left-hand one, we've got a definite inside function. Our inside is x squared plus 1. So let that be u. Du would equal 2x dx. But our leftover here is the x dx. So we've got to correct by a half. So this will now become the integral. We've got a 1/2 out front. We're going to have u to the negative 1/2 du. Because we had a square root on the bottom, it comes up as a negative 1/2. Now, something that's kind of convenient is notice the second one, we would want the same u. We've got a derivative, the numerator is 1 degree less than the denominator, so we would want u equal x squared plus 1, and we would eventually want x dx as well. So this would be plus 1/2 the integral, and we'd have 1 over u du. If the u wasn't going to match exactly, like if we were going to do a different substitution, technically we should use a different variable. But because it matched exactly, we can just reuse the u. So our new exponent will be positive 1/2. If we divide out front by a positive half, the halves wipe out. And then we'll have plus 1/2 natural log absolute value of u. And you're technically have a plus c on both, but those just combine to give you some constant at the end. And then just fill back in. X squared plus 1 to the 1/2, or you could write it as a square root. 1/2 natural log absolute value of x squared plus 1 plus c. Now this is a case where you could drop the absolute value. So if you wanted, you could write this as x squared plus 1 to the 1/2 plus 1/2 natural log, and then just x squared plus 1 plus c. Now what I would want to see on a test, I would want to see you have at least somewhere identified that you know that the antiderivative of 1 over u is natural log absolute value of u. If you showed that absolute value at some point, I am fine if even you had jumped to this step right here. If as you're subbing in, you're seeing, oh, x squared plus 1 is always positive, I don't need to put the absolute value bars in. As long as you have those absolute value bars in one spot, so it's clear to me that you know that what the antiderivative is for 1 over u, I'm okay then if you jump to that last thing and don't do the intermediate step. All right, next one. Notice this time our numerator degree is larger than the denominator degree. So we wouldn't be thinking like a 1 over u case. What we'd want to do here is we'd want to do division. So we're going to go through both types of division, just as a refresher, synthetic division and long division. So in long division, you put the x plus 2 on the outside. On the inside, we'd put each of our terms. And if you're missing anything, it's good to hold that spot with a 0 of that, but we're not missing anything here. We would want to know what times x gives us x cubed, so that would be x squared. Multiply it through the x plus 2, and you'd get x cubed plus 2x squared. And then we subtract everything. So x cubed minus x cubed is 0. 2x squared minus 2x squared is 0. So those are all gone. So you just bring down the 4x plus 5. And now you ask what times x gives you 4x? Well, that would be positive 4. If we multiply it through, we get 4x plus 8. And we've got to subtract the entire thing. 4x minus 4x is 0. 5 minus 8 will give us negative 3. Nothing times an x will give us a constant, so this is our remainder. We have minus 3 over x plus 2. So that's the long division way. That will work in every scenario. Because we have a linear factor in the denominator, we can do synthetic division. So we make like our little box. On the left, we put whatever would make the denominator 0, which in this case would be negative 2. Inside the box in the top row, we put all of the coefficients. So 1, leave a little space 2, leave a little space 4, leave a little space 5. And make sure you have room for a second row of things there. If you were missing any terms, you need to hold the spot with a 0. So now we'll drop the first number down. You always do that to begin. And now we're just going to multiply and then add. So we multiply the 1 and the negative 2 to get negative 2. And then add them, so we get 0. Then we multiply the 0 and the negative 2 to get 0. Add them, we get 4. Multiply to get negative 8. Add to get negative 3. Your degree of your answer is always 1 less than the degree you started with. So we started with x cubed, so we would have 1x squared, no x's, constant, and then remainder, so minus 3 over x plus 2. So either case gets you to the same thing. So we're going to have the integral, and we're going to write them separate because we're going to have to do some u substitution for the second part. That part's going to be easy. And then we'll have minus the integral, and I'm going to put the 3 out here too so we don't have to worry about it, of 1 over x plus 2 dx. Okay, you could have left the 3 on top if you wanted. So let's work with the second integral. We'll come back to the first one because that's going to be easy. In the second one, we can let u equal the x plus 2 because the degree of the numerator is 1 less than the degree of the denominator. So du is just 1 dx. So this is going to be minus 3 integral 1 over u du. So this will be minus 3 ln absolute value of u plus c. Or in other words, minus 3 natural log absolute value of x plus 2 plus c. And then we can just carry down the antiderivative of the first one, which is pretty basic, 1/3 x cubed plus 4x. So we knew to divide because the numerator degree was larger than the denominator degree. All right, one last one for this video. We want to find the average value of this function on the interval 1 to 4. When you do average value, we always do 1 over b minus a, and then the integral of our function. So when we do 1 over 4 minus 1, we'll get 1/3. We're doing the integral from 1 to 4, and we have 2 over 1 plus 2x dx. So our numerator degree is 1 less than the denominator degree. So we would want to think making u equal the denominator. So du is just 2 and swing over our dx. So this will be 1/3 the integral. The 2 dx's are left over. That's our du. We'll have 1 over u. And then we've got to change our bounds. When you sub in the 1, 1 plus 2 times 1 gives us 3. 1 plus 2 times 4 gives us 9. We'll do our Antiderivative, ln absolute value of u, we're going to evaluate it from 3 to 9. So we could have 1/3, leave the 1/3 out front with a parenthesis, we'll have natural log of 9 minus natural log of 3. Free response question, that's a full credit answer. Let's talk about some ways that we could simplify it, because it could be simplified differently if it's a multiple choice question. When you subtract logs, you divide the insides. So this could be written as 1/3 natural log of 9 over 3. So in other words, 1/3 natural log of 3. Probably the most logical way you would see it written, but you could also remember that any numbers out front could have come from exponents. So this could also be written as natural log of 3 to the 1/3, which is the same as saying natural log cubed root of 3. So anything in here would be a full credit answer on a free response. Okay, just need to be comfortable with the ways you could rearrange it in case they have it rearranged in a different way for a multiple choice. That's it for this video. Make sure to do your homework tonight and submit it, and we'll see you tomorrow in class.